Hello and welcome to another video. We're going to be working on a number of pairs of interchangeable rectangles today. So in this problem, you're given n rectangles represented by 0-index 2D integer array rectangles, or rectangles i's width and height denotes the width and height of the ith rectangle, and two rectangles are interchangeable if they have the same width-height ratio. More formally, two rectangles are interchangeable if width and height of I is width and height of j using decimal division. Return the number of interchangeable rectangles. So in this first example, we have four rectangles, and you can actually see that all of their ratios are actually 1/2, right? So this is 1/2, this is 1/2, this is 1/2, this is 1/2. So they're all interchangeable. So if you label them rectangles 0, 1, 2, and 3, then you could say like 0 is interchangeable with 1, 0 is interchangeable with 2, 0 is interchangeable with 3, 1 is interchangeable with 2, 2 is interchangeable with 3, and also 1 is interchangeable with 3, right? And notice here there are no repeats. Like you're not writing this also. It's number of pairs. So each pair only counts one time. So you don't want any repeats. So from other problems we've done, you need to recognize that this is a combinations problem, right? This is a combinations problem. And combinations means you don't have duplicates, right? So permutations would be like all of these would be doubled because you'd have 2, 1 and 1, 2. You'd have 2, 1 as well. But this is combinations. So what we really are asking in this problem, if you notice, oh, by the way, so in the second example, there are no pairs, but really what we're asking is like, the subproblem of this problem is like, given x rectangles, like let's say we just have like 8 rectangles, how many pairs of interchangeable rectangles are there? Like let's say you have 8 rectangles with all the same width-height ratio. How many pairs of interchangeable rectangles are there? And that's the problem we're really trying to solve for. And then from there, I'll show you how to do like the bigger problem, but this is the subproblem that we need to do. So for combinations, you're going to want to actually know this formula, I think, and for permutations as well. So the formula for number of combinations of from n numbers, so we have n numbers, and the combination length is k, is actually n factorial over k factorial, and then n minus k factorial. And you're going to want to know this one because it comes up quite a bit, or at least in the last few problems it's come up quite a bit. But it's not super hard and it's quite useful. I think there is actually a Python I think there is like a Python NCR and NPR command as well. You could learn those as well, and that will just give you the number. But we do have some issues here. Like let's say we have, these constraints are pretty big. I think these constraints are like 10 to the 5th. So what if we just had like a ton of numbers, right? Like let's just say we had n is, like 1,000. Well, n can also be 1,001 and so on, right? And so this gets really big really fast. Like 1,000 factorial, that's not going to be, we need a linear time solution. So that's not really going to work. But if you notice, let's try to actually use this equation for a few numbers and kind of see what we get. So let's say for 8, what would this be? So we're getting n is 8 and k is 2 for all of these, right? Because we're getting pairs. So all our combinations are length 2, and we have 8 numbers to choose from in our example. So if n is 8, we have 8 factorial over 2 factorial, and then 8 minus 2 factorial. Okay. Okay, 8 minus 2 factorial. Okay, so what is that going to be equal? Well, it's going to be equal to 8 factorial. So 2 factorial is just 2. Then we have 6 factorial. So you can do factorial simplification here, right? Because 8 factorial is 8 times 7 times 6 factorial. And this bottom part is 2 times 6 factorial. So you can see these 6 factorials cancel out, and then it's actually 8 times 7 over 2, which is, so if we have n, it's going to be like n times n minus 1 over 2, and then that's a linear time. Like we can get that in linear time, right? Even if our number's really big. So let's try this for another number just to double check our work. So let's say n was like 1,000, right? So if n's 1,000, we're going to have 1,000 factorial over k factorial, which is just 2 factorial, which is 2, and then n minus k factorial, which is going to be 1,000 minus 2 factorial. And this is like the crux of our problem is we can use really big constraints because we only have pairs of 2. And so a lot of this cancels out. So let's try this. So we have 1,000 factorial over 2, and then this is 998 factorial. And so once again, we can simplify this to 1,000 times 999 times 998 factorial. And so this is just 2 times 998 factorial. These parts cancel out, and we have the same thing, right? N times n minus 1 over 2. And so that's how you can figure out the number of combinations given some rectangles. And that's going to be like the toughest part of a problem. This is linear time. This is a linear time operation. So now that we know how to do that, how do we actually like get all our pairs of rectangles? Well, that part is actually going to be pretty straightforward. So we can simply just calculate the, so they're asked for the ratio of width and height. So we can literally just say, let's just go through our rectangles and just get width over height, get that number, and then let's just store these in a hash map, and then let's update the count every time we get that, right? So we could just have a hash map like for count or something. We'll call hash map count. And then like the way this would work for this, for example, we do like, okay, what's our width and height ratio for 4 and 8? It's 1/2. So let's just go key 1/2 equals 1. Here, this is our count hash map. And then for 3 and 6, it's also 1/2. So key 1/2, let's add 1. So that's going to be 2, then it's going to be 3, then it's going to be 4, and so on. And so at the end, you're going to have a bunch of keys that are just all your ratios, right? So you're going to have some keys that are like 1/2, 3/4, whatever it is. And then you're going to have counts, right? So you're going to have like 3, 4, 5, whatever. And so finally, once you have these like ratios and counts, you don't even really care about what the keys are. You just need to take the counts and you need to figure out like how many pairs are there for each count. Right? Because it doesn't matter that you have, 6 keys with ratio 1/2. You just need to know there are 6 interchangeable rectangles and you need to make pairs out of them. The ratio doesn't really matter. And so once you get this hash map of keys and counts, let's actually draw some stuff over here. Like, let's say you get a hash map of keys and counts. We can just get the values. So let's say we have values, 4, 8, 6, 15, whatever they are. For every value, we can do our operation to figure out how many combinations there are, right? We can just do the n times n minus 1 over 2. And let's see if this works for, some smaller values. So what about like if we have 2 numbers? What would this be? So it would be 2 times 1 over 2, which would be 1. And there's only one way to do it, right? There's only one pair. So that works for that. What about for number 1? So for 1, it's going to be 1 times 0 over 2, which is 0. And that also makes sense because if you only have one number, it's going to be, you're not going to have any pairs. And then for 0, it also works, right? So it's going to be 0 times negative 1 over 2, which is 0 pairs as well. So this actually does work for every single number we have. So now we kind of have like an algorithm to do, right? So we can write this down. So we can say, let's make a hash map where the key is the ratio and the value is the count of rectangles with that ratio. Once we go through all the rectangles, let's just take all the values in the hash map and let's apply our formula to them and add all those results, right? So it's pretty straightforward kind of once you get, the simplification of this part here. Like once you get this, it's pretty straightforward, and you have to recognize, like, oh, I can actually do this in linear time because most of this stuff cancels out. But once k gets bigger, obviously it's not going to cancel out. Like let's say you have, n is 1,000, k is 500. That's when you run into issues. That's where the constraints would be a problem, because then you'd have like 1,000 factorial over 500 factorial over 500 factorial, right? And that's going to be a problem for you, I think. Okay. So now that we know how to do this, I think we have enough to be actually coding. So let's do that. So here's our solution. And so let's go through it. So what do we need to do first? We need to make a hash map, right? So we can just say like count or something. Let's make a hash map. And then we need to make a result. And then we could say like for, I think this is width and then height in rectangle. Hopefully I'm right there. So width, height. I guess it doesn't really matter because it's a ratio. So even if it was height width, the ratio would work out the same way. It wouldn't really matter. Rectangles. So what we actually want to do is we can just have a default dict here. We can have an int. So we can just say like, okay, for width and height, let's just say counts. This is going to be width over height. Yeah, and I wasn't sure if you could store a float as a key because like maybe you'd have some issues there, but I guess you can. So good to know. So counts width over height plus equals 1. And then actually I'll do that later. Okay, so counts width over height plus equals 1. Now we actually have our hash map done. That's all we needed to know. So now we need to go through all of our values, right? And we just need to add those to the result. So we could say like for value in counts.values res plus equals. And yeah, you don't even have to check for like 1 and 0. This thing works out for all of those. So res plus equals value times value minus 1 over 2. And we want to do a decimal divide here because if you do a float divide, you're going to get a float. So even if you like for the first one, even if you get like 6, you'd get 6.0. So you could do a decimal divide and then convert it to an int later, but you could just do a float divide or a number divide because these are always going to be integers for any number. Okay. So, because if you think about it, like for value and value minus 1, one of these is guaranteed to be even, and an even number over 2 is going to be guaranteed even, right? So if you have like 5 as your value, then you're going to have 4 as well, and whatever. So one of these is going to be odd, one of these is going to be even, and the even number over 2 is just going to be always even, so it'll work out. Okay, so now finally we can return the result, I believe, and I think that's it, but let's just double check. I think actually I have my submit button over here, so I need to put that here. So let's see. Yeah, and so you can see it's pretty efficient, and yeah. So let's think of the time and space complexity here. So for the time, what's it actually going to be? So we are going through the rectangles, and this is linear time, right? Like we're just going through the rectangles, adding them to the hash map, and then this is also linear time, like worst case scenario, this is length of rectangles. So that's going to be O of n. And then for the space, we did use a hash map, right? So that's also going to be O of n because worst case scenario, every rectangle has like a unique width and height, and that would be O of n. But yeah, it's going to be it for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.